All right, so we're going to try an application here of our max and min. And so we have here an X, which is the number of units. And this monopolist has a total cost of C, which is our cost. And then the price at which X units will be sold is P. So P is our price. And then we're also going to need R, which is our revenue. And our revenue here is what we bring in. It's our sales. And so that's going to be P times X. See, if price and units are P and X, then you multiply them together to get the revenue. So think about it this way. If you sold items for $10 and you sold 5 of them, you would get $50 for your revenue. So it's always price times quantity, price times units. We're also going to have a capital P here, and this will be our profit. And these problems are going to be talking about profit here. We want to know, when is profit increasing? What's the maximum profit? And everything about profit. So what does that mean? It means we need a profit function. So our profit here is always revenue minus cost. So if we take the revenue function, which we haven't created yet, revenue is price times quantity. So all that means is if you take the price function, which is variable here, and multiply it by X, it'll give you the revenue function. So 50X minus 0.01 X squared. So if we take that, subtract our cost, make sure you put this one in a parenthesis so that you subtract both parts, both terms, we will get our profit function. So this is minus 0.01 X squared, and then I forgot the X here. So 50X take away 10X is 40X minus 5,000. And make sure that last constant, which is part of the cost, is always negative here for these problems. So now it says, over what interval are the profits increasing? And so we find our critical numbers. So remember, this is our parabola here. We're dealing with a downward slope parabola. So if we find our critical number, it tells us our interval of increase. So P prime equals negative 0.02x plus 40 equals 0. And so if we solve this, plugging that in our calculator, we would get 2,000. And X is the number of units, so it would be 2,000 units. So if you think about it here, that is an X of 2,000. And our profits can only start when we sell 0 units. So our interval of increasing for profits would be from 0 to 2,000. That would be our interval of increase. So over what interval are profits increasing? The interval from 0 to 2,000. So what is happening to the price over this interval? So now let's look at our price function and see what's happening from 0 to 2,000. So if we take that function and we plug it in, we know it's a linear equation. And so if we took the derivative of this function, you end up with minus 0.01. So if we want to see what is happening to the price over the interval, we take the derivative of the price. And if we have a negative slope, we know it's decreasing. So what's happening is that for our profits to increase, our price has to decrease. It's a nice little thing to think about here. So the key is to pay very close attention to what you want to know is increasing or decreasing, and that's the derivative you have to look at. So if you want profits, you got to look at profits. If you're looking at price, you have to look at price. So for what level of production is the profit maximized? So we already know it's going to be a maximum because it's a parabola. But if we did our little table and we put 2,000, we would know that P prime here is positive and P prime here is negative, giving us this shape. So it's a max. So for what level of production is the profit maximized? At X equals 2,000 units. So what it's asking is, how many units do you need to sell to maximize profit? 2,000 units. And now an even better question, what price do you need to sell that for to maximize profit. Now this doesn't mean you need to make an entirely new function in terms of price. It just means you need to take those 2,000 units and plug them in. See, the key is to focus on what you're maximizing. We are maximizing profit. And so all you have to do is take the profit function's derivative, and it will give you the derivative, which is the slope of the tangent, and tell us when we have a horizontal tangent. That is our max, regardless of what we plug in here. So if you take 2,000 units and you plug it back into the price function, all it's going to do is tell you what the price was. So when they're asking for what price, all you have to do is take the equation for price and plug it in. So 50 minus 0.01 times 2,000 units. That means they had to charge $30. So what price will maximize profit? $30. So if we put all this together, the price is decreasing. So if they take the price, which is $50 at 0 units, and they decrease it to $30, they will sell 2,000 units, which will maximize profit. And so then the last question is asking, what is that profit? So if we go to our calculator, we plug in our function, we go to our window and go, okay, well, we're going to be going to 2,000 units for the min, so we can go to 4,000 units to split it. Hit zoom 0, it'll graph our function and verify all our units. So 2,000 should be our max. See, that's a nice perfect parabola there. Trace 2,000, and it's perfect where it needs to be. So $35,000. See, that function we plugged in was the profit function. And so that's why everything has to deal with this one. So over what intervals are the profits increasing? We found the critical number to be 2,000. So from 0 to 2,000, the profits are increasing. You can even see that the profits are negative here. Then the next thing is what is happening to the price over this interval. So we went back to the price function, took the derivative, and it says it's decreasing. And then we keep going with this problem. So for what level of production is profit maximized? 2,000. If you plug 2,000 back into the price function, it tells us the price. And then if we plug that 2,000 back into the profit function, it tells us our profit. So those are our answers for everything. So if we sell it for $30, we'll sell 2,000 units, which will maximize profit at $35,000. Don't decrease the price anymore. We're good to go.